So that's good. Hey guys, welcome back. Can you all comment when you hear, because no one said anything yet. Hopefully it's not just me. So today we're going to go through, we're going to go over hypothesis testing, and I thought we'd do one of each type of hypothesis testing, and just to kind of distinguish for you which is which. Hey guys, thanks Jasmine. Could you guys comment when you're here? So today we're going to be looking at hypothesis testing, all the different types, so that you can compare and get used to the differences and spotting what kind of a question it is. So I'll just quickly do the register. Wherever it is. Cool. Oh, I can't do it yet. Still got 3 more minutes. Did I start the lecture early? Oops. Sorry, guys. Yeah, it won't let me do the register yet. So how is everybody? How's your 2 weeks off? Can't do the register. Sorry, guys. I shouldn't have started so early. I got a bit carried away today. Yeah. So, yeah. Yeah, so that's the plan for today. If you have not had your results back from the mechanics test, let me know, and I'll be emailing them out on Friday anyway, but if you want to go through them one-on-one and find out what you did wrong or what you did right, let me know and I'll do a Teams chat whenever you're free next. Right, I'm just going to roll the intro again so that I can edit out this awkward early early start to the lecture. So I'll be right back. So that's good. That's better. Cool. Okay. Welcome back, guys. Yeah. So just going to do a quick register for you today, and then we'll get started. If it works now. Yeah. Cool. Okay. No, I am legally not allowed to tell you that, and we haven't actually decided yet. So, yeah. So Dom, Jasmine, Jake, Emerald, Rob. Cool. Elizabeth, Grace, Jolie, Jack. Cool. Anyone heard from Poppy or Molly, Melissa, Ed, Dan, or Ollie today? Oh yeah, Molly. So you are. Yeah, cool. Okay, still missing a few, but oh, Ollie's here. Cool. Hey, Ollie. Anyone heard from Dan, Ed, Melissa, or Poppy? All right, we'll see if they turn up later. Yes, I'm not allowed to. Well, we haven't decided yet, and we're still kind of going over as a department how we're gonna sort this out. But I can link you to the government guidelines, but you've probably already been emailed by college. But I can't really tell you anything. Um, it's as secret as exam papers. So yeah, sorry, I can't really say much more about it. Um, yeah. Anyway, so I thought today we'd look at comparing the three different types of hypothesis testing. And then we'll kind of leave it and move on. Move on with something else. So yeah, and then I thought we could look at a stats pass paper. So we thought we'd look at the 2018 stats and mechanics paper, work our way through that together. Stream keeps buffering. Um, I think it's you, Ollie, to be honest. Mine, it seems to be all right today. There's a bit of a delay, but I've done that on purpose. Yeah, maybe. Yeah, so I thought we'd do this, work through an applied paper, and then revise some pure stuff for the next couple of weeks up until study leave, which, yeah. Cool. Has anyone got any questions before we start, though? No? Okay. So, what I'd like you guys to do to begin with is I've got three different past paper or from the textbook questions here, some are past paper ones. I would like you guys to have a think about which of these questions is which type of hypothesis test. So you got one, two, three. So I'll give you guys a couple minutes to read them through. Which one relates to which type of hypothesis test question? If you don't have them, Rob, I will be emailing them out on Friday. But if you want to go over them, we need to arrange a Teams chat. So I'm going to give you guys 2 minutes starting now to have a go. Just working out what kind of question these are at the moment. So we're not asking you to do them, just to identify the type. Why have I got delay, Ollie? Because I had ridiculous lag yesterday, and the delay seems to let it buffer a bit before it streams, so there's less lag for people that way. So I've set up a tiny delay. I think it's only like 5-6 seconds, but it does help. So having a look and trying to identify which type of hypothesis test each of these is. Hey Melissa, cool, I've swiped you in. Cool. All right, if you guys could post in the comments which 1, 2, and 3 relate to in terms of what kind of hypothesis test, and we'll see what you went for. Hey Ed, just swiping you in now. So what do you reckon? Which test relates to which question? Anybody? Any ideas? Guys? Anybody there? Painful. First is two-tailed binomial. Yeah, well spotted, Dom. Thank you for posting anything. So yeah, the first one is a yes, there, I'm speaking. Yeah, first one is a two-tailed binomial. Done. You check sound out. Or is there more lag than I expected? Maybe there's a delay. Maybe it's worse than I thought. Don't know. Anyway, first one is a two-tailed binomial hypothesis test. Yep. Second one is a normal hypothesis test. And the third one is what we were doing yesterday, which is a correlation test. So we're going to try each of these and just see how you get on. It will take probably half an hour, 40 minutes, but we'll have done each one in sequence. And hopefully you'll remember how to do each different type. So first one is the binomial hypothesis test. So if you guys could try this one. There's more lag than I thought. Yeah, maybe. We'll see. Yeah. If you guys, I'm gonna start a timer. If you can tell me when a minute goes on the timer, I'll be able to work out what the lag is, and maybe. Well, it's too late to fix it now. We'll just have that awkward lag. Damn. Oh well, there's a bit of lag. It's fine though. Cool. All right. If you guys could try this, there will be some lag, but that's okay. So this is a 8-mark question. I'll give you 8 minutes to do it. So yeah, make sure you comment your answers because I'm not gonna wait. When it gets to 0, we need to go through it. Otherwise, there'll be like an extra 2 minutes plus 2 minutes for lag. So when the timer ends, please have some comments written, or it's gonna be painful me going. Wonder what the lag is. So yeah, if you guys could post a comment when it gets to 7 minutes, and I'll be able to calculate how much lag we actually have. Would be good. So type um, type 7 when it says 7. So Emerald, you got 20 seconds of delay. That's not too bad. Molly, yours is 30 seconds. Jasmine, yours is 40. Ollie, yours is about 40, 43, 45 seconds. It's interesting. Different internet speeds, I guess. Anyway, give this one a go, guys. You got 6 minutes left. Jolie, that was pretty good. Cool, I see. Gotcha. So give it a go, see if you can remember from last year. We did a few of these, I think, early this term, but see how you get on. Yeah, Jack kills isn't, it doesn't seem too bad now. We're talking 15 seconds. That's all right. I think it's just Ollie buffering earlier. Everyone was just everyone was trying to work out how lagged they were. Cool. Right, let's try and go through this then. So, first bit, suggest a model and state suitable null and alternate hypotheses. So the model, we just got to choose a letter. So let's go for x is binomial. Number of trials, 25. And 1/5 is our probability of success. And we say where x is the number of customers choosing lasagna. Cool. Okay, suggest state suitable null and alternate hypotheses. So null hypothesis is that the probability is 1/5, and the alternate hypothesis, if we read through the question, she believes it will change. So she believes it's going to be different. So we're going to say probability is not equal to 1/5. We ought to say what P is, where P is the proportion. You could use probability, proportion of customers choosing lasagna, or the probability of a customer choosing lasagna. Doesn't really matter. Okay, so that's the first bit. I'm going to get rid of that now to make some more space. Cool. Okay. Thanks for letting me know. So if I write the hypotheses again, H0 P is a fifth, H1 P is not a fifth. Cool. Okay, so we want to find the critical region at the 5% level. So because it's a two-tailed test, so actually this isn't normal, it's binomial. We want to try and find the two regions where the probability is 0.025. Or as close to it as we can get. Okay. Next thing is the most likely outcome would be a fifth times 25. So the most likely outcome is 5 customers. So that gives us an idea of the middle of the data. And we're going to search the lower tail and the upper tail around there. So lower and upper. Okay, so if we get the calculator up, I'm going to try and fit this in. Yeah, it's not too bad. So we're going to get distribution. Because we're using the graphical, it's a bit more annoying. And we've got to type in the lower and the upper bounds for all our values. So if we do the lower tail first, we're going to type in 0, and if we go from 5 down to 0, so 5, 4, 3, 2, 1, 0. On the class Wiz, it's a bit easier. You can just type in 5, 4, 3, 2, 1 because it always does less than or equal to. And just need a 0 there as well. Cool. So we're going to go to distribution. We're going to go to binomial distribution, BCD. Our data is now in a list. The lower values, which will 0 all the way down, is in list 1, and the upper list is in list 2. Number of trials is 25, and the probability of success is 0.2, which is a fifth. So there's our probabilities. So if I write all these down, just so you can see what's going on. We got the lower values, so we're looking for probability x is less than or equal to 5, 4, 3, 2, 1, and equals 0. And then those are the values we got. So 0.6166, 0.4206, 0.2339, 0.0982, 0.00273, and the last one, which is in standard form, but we can convert it 0.00. Is that right? Oops, I put in one extra zero last time. 0.003.8. Okay, so we need to look at that list and decide where the 2.5% is. So this value here, if you guys can see, no. Second from the bottom, this one here is 2.7%. So 2.5 is going to be between there and 0. So we're going to be using 0 as our critical value. So that's our first critical value there, x equals 0, which I'll write in there. The upper ones on the class Weds are slightly more difficult because remember we need to do 1 minus a probability. So if I get rid of those now, for the upper ones, let's look at, I don't know, greater than or equal to 8, 9, and 10, maybe 11. And to do those on the class Weds, you'd have to do 1 minus the probability x is less than or equal to 7. But that would all work out fine, it's just an extra step. So because we're doing it on the graphical, we don't have to do that. So I'm just going to change my lists. My upper now is going to be 25 because that's the most people we could get. So if the lowers, we're going to go 8, 9, 10, and 11, and delete anything else. And the other values are going to be 25 for each of them. Oh my god. Cool. So you go distribution, binomial, BCD. Everything else is the same. Hit execute. There we go. So greater than 8 is 0.1091. We get 0.0047. Sorry, 0.47. 0.017. And 0.0056. Okay, so we want again the 2.5% level. This one here is going to be the this will be 1.7%. This will be 4.7%. So we want it in between those two this time. So my critical value is going to be greater than or equal to 10. So if I add that in, our critical regions are x equals 0 or x is greater than or equal to 10. Cool. Okay, I wish I'd written down those probabilities now because I've just deleted part of the thing we needed. So with a hypothesis test, you would then compare your statistic to those values, and the actual significance level, or as they've worded it, the probability of incorrectly rejecting H0 is the two percentages added together. So you've got 0.017 as one of them. The other one, I think I did earlier. I hope I did it earlier. I don't know what I've done. I did, but it's gone. Does anyone remember what I wrote earlier? I guess you could skip back. Maybe nope, they've already gone off the screen. I'm just going to rewind on my other. So we got 0.00038, I think was the percentage earlier. So 0.00038 plus 0.017. Is that right? Yes. Okay, so if we add those two together, that's going to be our actual significance level, which will end up as 0.017 plus 0.0056. 2.26% is my actual significance level, which is also the probability of incorrectly rejecting H naught. Cool. Has anyone got any questions? The only other thing they could do with this one is then say, okay, well, she found that 12 customers bought lasagna. Has it changed? Well, yes, 12 is greater than 10, so it would be part of the critical region, and we'd reject H0 and accept H1. Okay, let's try the next question. So hopefully that's fine for everybody. So we're now going to be looking at the, I think it was a normal one, this one. So normal sample mean hypothesis test, which is what we were doing the week before the Easter holidays. So if you guys could try this, see what you can remember. It's 12 marks, so I'll give you guys 12 minutes on it. Do comment if you need help or if you've got a solution or an answer. No. You need to use Z for part A, but for the rest, you don't actually need to use Z. You can do it that way. It's not much slower, but I think it's faster to just use what you've already got, rather than go in and use Z again. All right. Let's get back to it then. All right. So I'll do a sketch so you can see what's going on. So we've got that's a bit smaller than that. We need some space. There you go. So we got cats for standard weight. We'll come back to that bit in a minute. This is the bit we need. So 2.5% of cats weigh less than this. So this value here, 3.416. We know the area there is going to be 2.5%, so 0.025. And we know 5% of cats weigh more than 4.858. So this area here is 0.05. So we're going to find the corresponding Z values to those probabilities, and then we're going to use the coding Z equals X minus mu over sigma in order to find mu and sigma, and then we can use those to actually answer part A of the question. So I'm going to bring up the calculator. There we go. And we're looking at a normal distribution, inverse normal, because we know the areas. So we'll do the variable, we'll do the left tail first. And the area there is going to be 0.025. Sigma is 1 and mu is 0 because we're using the standardized normal distribution. And we get a corresponding Z value of minus 1.96. So that value corresponds to 3.416. I'm going to do the same thing. I'm going to put the tail to the right this time. If you're on the class Wiz, you'll have to, and it would work just the same. So hit equals, and it gives you our Z value is 1.645. Okay, so the point of that was so that we can uncode those Z's to find mu and sigma. So we're going to write out the green equation using the bits we just got. So minus 1.96 equals 3.416 minus mu over sigma, and 1.645 is 4.858 minus mu over sigma. So if you times up each by sigma and solve them simultaneously, you will get mu is 4.2 and sigma is 0.4. All right, now we've found those, we can actually do the question. So I'm going to get rid of all this. I'll write mu and sigma back up at the top. There we go. Cool. So we want to find the proportion of cats that weigh between 3.5 and 4.6. So we want to find this area here. So we can just do this as a easy normal question. It's going to be cumulative between those two values. So distribution, normal, bring up the calculator so you guys can see. Bring up normal. NCD, our lower is 3.5. Our upper 4.6. Sigma is 0.4. And mu is 4.2. Draw it to make sure you haven't made a mistake. That looks good to me. And our probability there should be 0.8015. Cool. Has anyone got any questions about that? So we use the Z distribution to find mu and sigma, and then we use mu and sigma to find the area. Okay. Next bit, part B, is actually a binomial question because we've got a sample size 15. No, sample size 10. So we've got X, B, sample size of 10, and probability. We want them to be standard weight. Well, we just worked out the probability of being standard weight. So we get 0. Do that again. So 10, 0.8013. And we're trying to find the probability. Sorry, 15 cats are chosen. That should be 15. We want the probability X is at least 10. So back to the calculator again. This time we're doing a binomial question. So distribution, binomial, BCD. We got our lower is 10 and our upper is going to be 15 because that's how many cats there are. Number of trials 15. And our probability of success is 0.8013. Cool. And our answer is 0.94. 0.941. Okay, last bit then is a a normal hypothesis test for a sample mean. So if I get rid of all that. Part C, second term. Cats are also normally distributed, so we're going to do weights, mean weights, normally distributed, and we're trying to test if the mean is different to 4.5. So that's going to be the means that we're testing. Standard deviation is 0.51, and we're going to divide that by the sample size of 12. And we're trying to find if the cats are different from 4.5. So we're going to have to try and find two different critical regions with 5% each. Cool. And then we're going to compare that to our test statistic of 4.73 and see whether we agree with our hypotheses. So H0 is the mean is 4.5. H1, the mean is not 4.5. So on the calculator, if we go to normal distribution, we know the areas, so we're going to go inverse normal. So we do tail to the left first, and 0.05 there is correct. Sigma is going to be 0.51 divided by the square root of our sample, which was sample 12, I think. Yep, 12. And our mu was 4.5. Cool. So if we do that, we find our lower critical value to be 4.26. Our upper value, all we need to do on the graphical calculator is change the tail to the right. On the class whiz, you just do 1 minus the area. If we work that one out, we get 4.74. Okay, so now we need to compare our value. So our value over here was 4.73. We're comparing that to 4.74. 4.73 is less than 4.74. So in other words, 4.73 isn't in this critical region. It's slightly below it. So we're going to say not critical. So accepts H0, and then we can say there is evidence to suggest that the weight of the cats is not different to 4.5. So evidence to suggest the mean weight is 4.5. Cool. All right. Anyone got any questions about that one? No. Okay. We're going to try one more then, which is going to be the Oh, where's it gone? Come on. There you go. So we're going to try the one about correlation. So 4 marker. I'll give you guys 5 minutes to do this one, and then we're going to move on to start working our way through a past paper. So 5 marks on the timer. 5 minutes on the timer. What we're talking about. 5 minutes on the timer. If you guys get started with that, message in the chat if you need any help, or if you get an answer. Cool. All right, let's go through this. It'd be nice if you guys could try and get these done in the time I set, but yeah, maybe you find them difficult. If so, watch the videos again from yesterday. Anyway, so we've got a hypothesis test for our correlation. And we've got 1, 2, 3, 4, 5, 6, 7 data points. So we're going to need the 7th row because we got 7 in our sample. And we're testing at 2.5 significance level. So that's going to be this one here. So the value we're trying to compare to is going to be 0.57545 is critical. Now we're looking at negative correlation. So that number actually needs to be negative minus 0.7545. So if we find a correlation that's closer to -1 than that, then we found a critical value. Right, before we actually do this, let's state our hypotheses. So H0 row is 0. H1 row is, in this case, negative, so less than 0. Okay, so if we bring up the calculator, we want to type in all of that data into some tables. So if I go through deleting them. All right, so we've got 17.5, 18.5, 18, 24.6, 22.2, 23.1, 27.3. Same again in the list 2, so 1010, 1011, 1012, 997, 1009, 998, and 1002. Okay, remember to just do a quick setup. So check, go calc, set. Just make sure they're in the right place. So we've said X is list 1. So we've said X is the temperature. We've said Y is the pressure. Because the temperature is going to affect the pressure. Pressure won't affect the temperature. So we go back and we're going to go to regression, X regression, A plus BX. We get R. That cannot be right. What have I done wrong? Let's double check, see if anything's happened. That should be 1012. So 1012. There we go. That looks better. Okay, so we got our R value is minus 0.792. So is that more correlated than our critical value? Yes, it's closer to -1. So that is less than minus 0.7545. So we'll say, therefore, critical, therefore, negative correlation between mean air temp and mean pressure. H1. There you go. Cool. Right, so that's the 3 different types of hypothesis testing. In each case, we've got a sample. We're looking at a parameter of the sample to test whether it fits the population. So we found for this sample, the correlation in our sample is strong enough to suggest that the 2 variables, temperature and pressure, are correlated in the population. So that's the whole point of this thing. Right, anyway, so for now and Friday, I want to try and get through a past paper, which is the 2018 applied paper. So we're going to start today. We'll do the same kind of thing like we've done so far. So I'll give you a minute per mark and we'll see how much you can get through. Yeah, so if you guys would like to start with this one, it's a 5-mark question. I'll give you 5 minutes for it. I think some of you might struggle with this, so please ask for help if you need it. But this is all to do with your probability distributions from first year. So 5 minutes, guys. Let me know if you need any help. Why do I keep muting myself? So yeah, the sky is measured in octaves, which are eighths of the celestial dome, which is something we did last year. So if we're splitting the sky into eighths, these are all the possible outcomes. We could have no eighths, 1/8, 2, 3, 4, 5, 6, 7, or a completely cloudy sky. So we need to work out the probability of these, and the probability comes from the fact they've called it a discrete uniform distribution. So remember, uniform means the same. So our probability are the same. So if the probabilities are the same, but they've got to add up to 1, each of these must have a probability of 1/9, because there are 9 different outcomes. Cool, so for each value we have a probability of 1/9. Okay, and now we're just going to be using this. So part B, using the model, find the probability the cloud cover is less than 50%. Well, less than 50% cloud cover would mean that there are less than 4 as my cloud cover. And 4/9 we can write down is 0.44 as a decimal. Okay, cool. So that's part 1 and part 2. Next, but then I'm just going to get rid of this. Comment on suitability of Helen's model in light of the information. What was the information say? It says when she looked at Hearn's data, the proportion for days of cloud cover were less than 50% was 0.315. So Helen's model gave us 0.445, but in actuality it was 0.315. So what would you reckon about the suitability of her model? I would say not suitable, out by, that's quite a lot. To be out by, it's almost a third of the data, so about 30%. So say out by a lot. Model is bad. Yeah, so because the numbers are vastly different, it's not a very good model. D, well, what's wrong with the model? Problem with the model is it's a uniform distribution. A uniform distribution, it's good if you got something like a dice or something like that, but for something that's happening in real life, like cloud cover, very unlikely to be uniform. So we could say, suggest an appropriate refinement, use a non-uniform or a continuous model. I can't draw that for some reason. So using non-uniform or continuous model. Cool. So really just asking about your understanding of kind of how models work and whether a value it gives you is appropriate or not. Okay, next question. How long are we doing? Yeah, we're doing all right. So next question is about correlation. So this is basically testing what we did in yesterday's lecture. And this is a 7-mark question, so I will give you guys 7 minutes to do it. This might be the last thing we do today, so give this one a go. Comment your answers when you get them, and we'll see how you guys do. Yeah, we finished the new content yesterday, really. The hypothesis testing for correlation was the last bit of new material. So from now on, we're just revising. till the end of term when you would have broken up for study leave. So I think it's five more weeks. So this week and four more after this is all that you guys are kind of obliged to attend by the college. I don't know. I understand it's confusing, but you still need to revise for the exams in case you do need to take the exams, if that makes sense. Read the government's briefing on what the plan is, and then you might understand why it's still worth understanding the content up to the grade standard you wanted anyway. Does that make sense, Ollie? Sorry, it's hard to explain. Sorry. Ollie, yeah. The government said you can't be judged. Yeah, you can't be judged on work done after lockdown. But having said that, if you disagree with the grade you were given based on the work you did before lockdown, you would want to retake either in October or next summer, which is the two proposed times. And if you had to retake it, you'd want to know all the stuff. So that's why we're still doing the lectures, and that's why you really ought to still attend them, is so you can actually understand the content well enough to, in case you have to prove it to somebody that you do deserve a grade or whatever. Yeah, but the appeal will. I don't know what that will even involve. I think they would just say retake it then. Honestly, I can't remember what it said about appeals, but I don't see why that would change a grade when they can just make you do an exam. So yeah, I really think it's worth making sure you know stuff as well as you would have going into an exam. Anyway, so small closed shop seaside town weekly sales figures. PMCC is minus 0.915. So we're trying to do a hypothesis test at the 5% level for sales figures. So, okay, 8 weeks in the summer, so our sample size is 8. So that would be this row. And 5% level of significance is going to be this one here. So our value to compare it to is 0.6215. Okay, is our correlation are we more or less correlated than the value in the table? We are much stronger correlated. So state your hypotheses clearly. So let's do the hypotheses as well. So h naught rho equals 0, h1 rho is less than 0. So minus 0.915 is in the critical region. Therefore, accept h1. I'll go through that at the end, Ollie. I want to get through this question. Accept h1. Cool. So, so yeah, accept h1. The correlation is negative. Yeah. Okay. Suggest a possible reason for the correlation. So we've got a seaside town in the summer, and our two variables are temperature and sales. So a reason for the correlation could be when it's hot, when there's sun, when the temperature's high, people will be at the beach instead of shopping. So people at beach instead of shopping. So you suggest a linear regression model can be used. Okay, state whether it's consistent. So yes, it's strong correlation. So strong correlation does suggest a regression model would be applicable. So yeah, strong correlation. Good for regression model. So we've proved it's strong correlation, so therefore it's linear data. So a linear regression line does make sense. Okay, which would be the explanatory variable? So the temperature is going to affect the sales. So temperature is our explanatory variable. And give an interpretation of the gradient of this regression equation. So if I get rid of this writing here, the gradient is minus 171. So any gradient is the rate of change of one variable with respect to another. So for every extra 1 degree, of temperature. The what's it called? The sales drop by £171. So that's our interpretation. Cool. Right. Anyone got any questions about that? If you do want to stick around and talk about grade allocation and stuff, I'll tell you what I'm allowed to tell you guys, which isn't, I don't think is cool. Any questions on this then? If not, make sure you're doing the assignments, guys. They're all up on Moodle. Get them done whenever you want, whenever you can. We've finished the content, so you should be able to do them all now. Upload those. I'll look through them, give you back feedback on those, and we'll keep going through this paper on Friday, and then next week possibly start looking at pure again. Cool. All right. Cheers, guys. So yeah. Well, this is the problem we've got. We've got to assign each of you a grade, and we've got to assign each of you a ranking based on how secure within that grade we think you were based on the whole year's results. So it's going to be a massive job for us to do, and we're trying to work out how we can do this. So we're looking at all the data we've got. We've got test results from in class. We've got GCSE results. We've got AS results. We've got your AS mock results, so we can see how much you improved due to revision last year. We've got your mocks from January just done, and we got your lecturers' opinions over how hard you work, how much you understand things, and what we think you would have got in the exams. That's what the real question is we're trying to predict what we think you would have got. So we're doing the best we can. We want to be as fair as possible. We're going based on every bit of data we've got available, but it's still, it's a hypothetical, isn't it? Hypothetically, if things hadn't changed, what would you have got? We're going to make our best attempts to work that out fairly, but to make it completely fair, there's the option to retake if you don't agree with the grades that we assign you, and then the exam board moderate. So yeah, that's why you still need to learn this stuff, is in case you come out of a grade you're not happy with, you don't think is fair. What happens if you do the exam and then get a worse grade than you've got given in the first place? I'm not sure. In the past, if you retake an exam, a worse grade doesn't replace a good grade, so that's what I imagine it was, but I don't think we've been told that yet. That'll be up to the exam boards. Yeah, well, we know that, Ollie. We're looking at everybody's, we're looking at everything, and we're looking at kind of last year everyone revised. You did mocks last year in your first year, and you did ASs last year in your first year. So we know what grades people went from and went up by. So we're trying to take everything into account, but we got to be as fair to everybody as possible, and we are trying to predict as accurately as we can based on what we know. So yeah, and we know as lecturers that students can be lazy and then ramp up stuff in the last term. That we're not disputing that that's a fact at all. Um, yeah, no, I know it's a stressful situation for you guys. You don't know what's going to happen, and it's whatever it is, it does feel unfair because you haven't had a chance to demonstrate the work you've done. They changed the rules halfway through, but there's not much we can do about it. This is just the nature of what's happened in this catastrophe. So yeah, I know it's not ideal. Try not to worry about it because everyone's in the same boat. Um, and if you do end up with a grade you're not happy with, retakes, appeal, everything, because we don't know what you get. We have to assign grades and then order students. So you might not even get the grades that we predict for you because everything still gets moderated like it would in a real exam. So moderation is still going to occur. So even the grades we predict for you guys, we don't know what you're going to end up with. I've already got enough guitars done. Thank you. Though. But no, we'll do things as fair as. But I think that's all I can say. Is just it's basically what's in the government's document um, that they've sent out. So yeah, cool. Anyway, stay safe and healthy, guys. If you want me to go through your mechanics test, we'll be taking everything into account that we can. Yeah. Jolie, that's a good point. Yeah, we'll look at what second years retaking first year have done, for sure. All right, cool. So I will speak to you guys on Friday, but just try not to worry about it. Everyone's in the same boat, but everyone's a bit unsure on what's going to happen. Yeah, I think so, Ollie. Because if again, what if you get a grade in economics you don't want and you have to do a retake exam? You may as well keep going to all the lectures so that you get better at those subjects. So I would recommend you just do things exactly as you planned before, and then if you do need to retake, you're prepared for it. That's the best advice I can give you, I'm afraid, because it's we don't know what's happening. All right, cheers, guys. See you on Friday.